Okay, this time we have f of x is equal to 2x minus 3x to the 2/3 power, and our closed interval is going to be from -1 to 3. So to be able to find these critical numbers, you've got to have your derivative first of all. Okay, now the fact that, and I actually meant to, this needs to be a 2 right here, because when you bring your 2/3 times your 3 is just going to give you a 2. Okay. All right, but now that you've got a negative exponent, we need to rewrite that. Okay, so I need to carry that to my denominator. And last, I want to get a common denominator here. Of course, this is understood to be over 1, so that means that I would have 2 times x to the 1/3 minus 2. So that's just getting a common denominator so I can write it all as one fraction. Okay, now remember, your critical numbers are going to occur where your derivative is equal to 0 and where your derivative is undefined. Now, a while ago, I only had a situation of where my derivative was equal to 0, but since I've got a fraction here, of course, when is this going to be equal to 0? That's going to be when your numerator equals 0. When is this going to be undefined? That's going to be when your denominator is equal to 0. So we need to set numerator and denominator equal to 0 to find these critical numbers. All right, so on this one, add your 2, divide by 2. And since this is a 1/3 power, then you can raise each side to the 3rd power, or you can say that you're going to take the cube root, or this is the same thing as cube root. Therefore, that means you've got to cube each side. So that would actually just end up giving you x equal 1. Okay, same thing. This is the same thing as a cube root. Therefore, you're just going to cube both sides. So you're going to get x equals 0. All right, so there's step 1. Step 2 is to evaluate the function at each of these values. Now, I mentioned this a while ago. Double check and make sure that these values are within this interval, this closed interval that you're concerned about. And you are. 0 and 1 is in here. So we need to evaluate our function at 1. Now, it doesn't matter whether you plug it back in here or down here, but substitute it in anywhere that you want to there with your derivative. But f of 1 is going to end up giving me -1. And then do the same thing with 0. Now if you substitute, and I said that wrong a while ago, I'm sorry. I said plug it back into the derivative, but you're supposed to plug it back into the function. I didn't write it down, so maybe you won't have to erase anything. I'm sorry, these are supposed to go back into your function. So if you substitute a 1 into your function, you're going to get -1. If you substitute 0 into your function, then you're going to get 0. Okay, now we've also got to test our endpoints. So I need to test the -1 and the 3. So if you substitute -1 back into the original function, you're going to get -5. And if you substitute 3 back into the original function, you're not going to end up with a nice little whole number in that case, or an integer value. You just have to round it off, and it's going to be about -0.24. Okay, now from this, my smallest value that I have is going to be the -5. So this is where the minimum is going to occur. And my largest value that I have actually is the 0. So that's going to be where my maximum is going to occur. Now I did go ahead and put this one on the calculator for us to look at here real quick. Now the 2 points that I have marked, you've got to keep in mind that we're actually only looking at a portion of this graph, because, I mean, if you, what you're looking at and you graph this function, this end keeps going off here, this end curves and keeps going on off up here, but we're only looking at it from x equal -1 to x equal +3. So this would be considered the end point, and this would be considered the end point, because this is x equal -1 and this is your x equal +3. So we determined that at -1, -5 was the minimum. That is the lowest point, you know, from here to here. Like, you're just blocking out the rest of this. That is your lowest point. And your maximum is actually occurring right here at the origin. This point is just a little bit below your x-axis. This actually comes all the way up to the origin. You know, so you can look at your graph on your calculator, just make sure you're looking at the section that is specified, and you can see if what you have found as your answer matches what you're seeing on your graph. Okay, next. Okay, so we've got to start by taking our derivative. Of course, 2 is just a multiple. So the derivative of sine is going to be cosine minus. Now, the derivative of cosine is negative sine. But then you have to apply your chain rule and take the derivative of the argument, so that would have to be a times 2. So you actually could just rewrite this as plus 2 sine 2x. Okay, now one thing about this example is the fact that your argument here is x, here your argument is 2x. We need our arguments to be the same. There is a trig substitution that we're going to need to do with the sine 2x, and this is something that you would have done in a trig course. You're not going to have any problems in your homework where this comes up, but other than the trig substitution, I liked everything else about this example, so I went ahead and did it. Just writing down, this actually has to do with double angle. You learned some double angle identities in trig, and sine 2 theta, or you know, whatever variable you want to use, is the same thing as 2 sine theta times cosine theta. So that means that I can rewrite this. So I'm just replacing, of course, this 2 is this 2, and now I'm replacing the sine 2x using this identity. Of course, I'll have x instead of theta. Okay, now to be able to solve this, what you can do now that you couldn't do a while ago is you have a common factor of 2 cosine x that you can factor from each of these terms. Okay, so what that does is it separates your sine from your cosines. Okay, so if you set your 2 cosine x equal to 0, of course divide by 2, you just get cosine x equals 0. Now, we're only looking at our closed intervals from 0 to 2, which is just your basic rotation. But cosine is going to be equal to 0 at pi over 2 and at 3 pi over 2. So I actually get 2 values from just that right there. Now, 1 plus 2 sine x equal to 0. So I would have 2 sine x equal to -1. So sine x is equal to -1/2. Now your reference angle here is going to be 30 degrees, of course, which is also pi over 6. And you're going to be in the third quadrant and the fourth quadrant. And that's because the value of sine that you have here is negative. So sine's negative, third and fourth quadrants. So in degrees, this would actually have to be 210 for the third quadrant and 330 for the fourth quadrant, and then you can just change that over to radians. So that would actually end up being 7 pi over 6 and 11 pi over 6. So we actually have 4 critical numbers that we're dealing with here. So we're going to have to evaluate our function at all 4 of these critical numbers, but also remember at each of the endpoints. Okay, so now I said it wrong a while ago, but corrected myself, but just reminding you, substitute these back into the original function. So first of all, you would need to evaluate f of pi over 2. So like I said, you're going to substitute that back into the original function. Now f of pi over 2, you should get a value of 3. And then I'm going to substitute in 3 pi over 2. At 3 pi over 2, you should get a value of negative 1. Now, I'm giving you what the answer is supposed to come out to be. You make sure that you can get this, okay? Then f of 7 pi over 6. Okay, that's going to give us negative 3 over 2. And then f of 11 pi over 6 is going to give us negative 3 over 2. I also have to evaluate it, remember, at each endpoint. So at 0, I get negative 1. And at 2 pi, I end up with negative 1. All right, so now comparing all our values here, like what's the largest, what's the smallest. Now, the smallest, and I actually have 2 of them that are the same, is the negative 3/2. So actually, I have minimums at both of those. So that just means that those 2 points, you have, 2 spots that are dipped down the same amount. Now, your largest value that you have here is the positive 3. So this is where your maximum is going to occur at, okay? Now, make sure that when you're substituting these values back into the original function that you're getting the answer. Don't just trust me that that's the answer. I've given you the correct answer, but you've got to make sure that you can get that answer, because if you have a problem like this on test, you've got to be able to do it on your own. I'm just not writing it all out just for sake of time for the video.